Hi, today we're going to be building a replacement power supply for a discontinued mixer which belongs to my friend Matt. The mixer in question is a Rodec Scratchbox, which is one of the most highly regarded turntablist mixers of all time. Unfortunately, one of the less desirable features of the mixer is that it uses an extremely non-standard external power supply brick, which is no longer available. Even worse, as you can see, the power supply is entirely potted in resin, so repairing it is out of the question. The only option we have left, therefore, is to build an entirely new power supply. Now, helpfully, Rodec have printed the power supply specifications on the brick itself, including the pinout of the connector. It's a dual 19V AC supply with a common center tap and separate earth connection. This should be pretty trivial to clone. Now here's all the parts we're going to need. First, the enclosure, which is manufactured by Takachi from flame retardant ABS and rather clumsily butchered by me with a Dremel and some files. Next, there's a power connector. I've decided to go with one of these standard IEC C13 inlets rather than the original power supply's hardwired cable, as it's good to be able to replace the mains cable if it breaks for any reason. In fact, this is actually what went wrong with the original power supply. I've included this nice fused connector as it's easier and more convenient than installing a fuse inside the enclosure somewhere. A small low-current fuse will be required, as typical IEC cables in the UK come with 10 amp or higher fuses, and in other countries they generally aren't fused at all. Next, there's a little grommet to secure the output cable to the hole I drilled earlier, and finally, and most importantly, the transformer. This transformer is made by a company called Mira, and it's probably overkill for our purposes. It's 30 VA instead of the 22 VA of the original, and it's fully isolated and potted in resin, but we don't want any overheating or safety problems, so I think it's a good choice. As you can see, it fits nicely inside the enclosure with just enough space for the connector. I should add, finding an appropriate enclosure was much harder than finding the transformer itself. So, we start by stripping, tinning and soldering wires to the earth, live and neutral terminals of the IEC connector. The solder point should then be covered by heat shrink tubing. This will add an extra layer of safety and meet the required double insulation standard required by mains voltage devices. Next, we need to thread the wires through the hole in the enclosure and attach the mains socket. It clips in very solidly, but we'll add some additional reinforcement later. Looking at the datasheet for the transformer, for 230 volt countries such as the UK, the primary windings should be wired in series. This is accomplished by bridging pins 4 and 9 together and wiring the main supply into pins 1 and 6. So we just cut, strip and tin a small section of wire and solder it across pins 4 and 9. Now we need to attach the transformer to the IEC connector. Plonk the transformer into the enclosure, trim the wires to the appropriate lengths, and then solder the live and neutral leads to pins 1 and 6. It doesn't matter which way round we wire these. Now I should perhaps have done this before soldering the mains connections, but we need a way to secure the transformer to the enclosure. I'm using these double-sided adhesive foam pads, which are great for this kind of thing. After peeling off the backing and giving the transformer a good push against the bottom of the case, we're ready to start connecting the secondary windings. Again, referring to the transformer's datasheet, we want to wire the secondary windings in series as well. This is again done by bridging 2 pins together, in this case pins 12 and 17. This bridge connection will also form our center tap, which the mixer will use as its 0V or ground reference. Note that this ground is distinct from the earth connection, which actually connects to the earth or protective conductor of the main supply and will be connected to the metal chassis of the mixer. The ground connection at this point is actually not referenced to mains earth at all, although the mixer will likely couple ground and earth together somehow in order to avoid interference. Different manufacturers have different approaches to this, but Rodec connect ground and earth together through a parallel resistor and capacitor inside the mixer. It's not something we really need to worry about though. Before doing anything else, we're going to do a quick sanity check. First, we need to carefully plug in the mains connector and get the trusty cheapo multimeter out. Measuring across the winding terminals on pins 14 and 19 shows 42 volts, and between the center tap and each terminal shows 22 volts. This is in line with what the datasheet says the no-load voltage should be, so everything appears to be working as expected. For the mixer cable, I'm going to use this YY motor control cable that I have a whole reel of just lying around. It's not really designed for this purpose, but it should be more than adequate, and in fact Rodec used YY cable of a much thinner grade in their original power supply, so I'm not going to lose any sleep over it. After threading the cable through the hole in the enclosure, first we're going to connect the earth, for which we'll use the green wire. We just solder it straight onto the mains earth, shrink some heat shrink around it, and stuff it down the side of the transformer to keep it out of the way. Next comes the ground connection. Let's use white for that. That connects to the bridged center tap connection we made earlier. Finally, we connect the other 2 wires by the 2 remaining pins. Just like with the primary, it doesn't matter which way around they go. To hold the cable tightly into the hole, we're going to use one of these little cable grommets. These are a bit of a pain in the arse to get in, but with a lot of squeezing with pliers you can get them in eventually. That's pretty much everything done on the actual power brick, so all that's left to do is to attach the connector at the mixer end of the cable. The Rodec uses a 4-pin circular connector that I believe is known as a GX12-4 aviation connector. I could be wrong about that. I'll update the video description with any further information I find. These are available on eBay, but I just reused the one from the old power supply. After stripping, tinning and soldering the cable onto the connector and screwing the connector together, it's time to test the power supply. Before that, however, we'll have to select a fuse. Since the old power supply was rated at 22 VA and we're in a 230 volt country, we just divide 22 by 230 to get our current rating, which is as near as damn it 100 milliamps. So we put a 100 milliamp fuse in the fuse holder and get the mixer set up. Once the power and an audio source are connected to the mixer, it's simply a case of turning the power on and it works. Hooray! Now we just need to finish putting the enclosure together. To stop the transformer rattling around inside, we're going to need to put a self-adhesive rubber pad on the transformer and another one on the lid of the enclosure to press against it. To get everything lined up properly, we can just balance the lid's rubber pad sticky side up on the transformer's rubber pad. Then when we carefully attach the lid, it will stick to the pad very nicely. This gives a very tight fit for the lid. We also want to secure the IEC connector with some hot glue to stop it popping out, and also hot glue the transformer connections to act as a strain relief and additional electrical insulation. Then all that's left to do is to screw the lid in and we're done. Although this project was pretty time consuming, I think building things from scratch is even more fun than repairing things, and it's definitely worth putting the time in to get a mixer like this working.